So here's a good example of thinking about the reality of things when you read them. Think about the reality of word problems. It's one thing we should do. Get a word problem. Don't get lost in the math. Think about what it means in the real world. That is an important skill in solving word problems well. Physics, chemistry, math, whatever. If you want to make sense of them, see what happens. We need to think about the real world, what's happening. Otherwise, we won't get it. I know I've seen that in numerous instances with what's a projectile? How do you work with projectile problems in physics? What about one where in calculus we were doing related rates? Someone was rolling out some dough to make a pretzel, and people didn't understand it because they weren't thinking about what would happen. You get some dough. It's in a ball or whatever. You roll it out. Same stuff, same mass, same total volume, but it's changing shape. You roll it out, it's getting longer and thinner. So the radius and length would be changing as you roll it out. If you think about what's going on, you get it. Or this one here, let's see, change my camera. I can show you this, see if I can do this really quickly. So preview first here, camera. I can't change it because I'm already using this. Dang. Automatic camera selection. Nope. Oh well. I will post it in the description field so you can read it. No, can't show it to you now, but you can read it in the description field so you can go straight to it. Yeah, so all good. So this is one that is like not going to happen. At least it's good that it's some problems, of course, in math. You need the word problem in isolation sometimes. I mean, a math problem in isolation sometimes. Let's get this, focus on it, learn how to do it. Then start making it real. Like sometimes, especially for people nowadays, they want to learn how to do something in a gym where it's safe. Then they can take it out to a more complex environment like in nature where there's all this variation, all these different things than in this little clean, squeaky clean, boring, uniform gym. Kind of the same all the time when you do this thing. You do a squat, okay, and it's important. Take it out into the real world, all kinds of variations. You don't know some cute little uniform bar where you can grab it and set up. It's not all like uniformly balanced. There's these awkward things you got to pick up. You can't have a little grippy handle. You got to get around something, grab it in different ways, know different grips for it. Your feet aren't going to be perfectly balanced. One foot might be a little higher than another because that's all you can do in given the situation where you are to pick something up. Lots of variation comes up. Get it and bring it out into the wild. When people don't do that, that's one reason they get hurt. Technique is something they train themselves. They kind of box in the context as it's in the gym. They don't take it out into a broader context and get this technique nailed in life. They don't have fitness for life. They're not really fit. They're fit for a zoo, fit for play. I mean, you're still strong in a gym and stuff. You know, you get what I mean. But I recommend gyms. I use them sometimes, good stuff. But you got to get that and take it out into the real world. So we get to something like this. And then this is good in that respect. But then there's something that's like total fail at being real and really thinking about what's going on. But this one, Sean is at the park spinning on a merry-go-round. His feet are placed at the very edge. His mom is standing 1 foot away, afraid that he might fall. Sean's distance d from his mom is a sinusoidal function of time. Suppose that at 1 second he passes his mom. It says his mom, but his mom, typo, minor. 4 seconds later, he passes her again. The diameter of the merry-go-round is 8 feet, so the radius is 4 feet. Why is that a fail? If we think about it and not just mindlessly do it, we should train ourselves to think about what's going on in the real world and what this means. What's the meaning? Then once we see this, we know never going to happen. Like you got this kid at the edge of a merry-go-round and the mom's afraid she might fall and she's going to stand here. Never in hell when hell freezes over that'll happen. No mom ever who's scared of her kid is going to fall off is going to do that. Some will. You might be scared, in a situation. You need to let your kid grow up, take risks. Depends on the kid and stuff. You got to judge. You'll stand here and watch and be ready to go in case you need to. But in this situation, if she's really afraid he might fall, no way. She's going to be going along with him. There's no sinusoidal function because she's always there. Fail. It's important to think about things when you're doing that. It's a good problem to work. I work this. I can't put a PDF because I can't share a PDF in the class description. But I don't know if I could arrange it somehow. I put some work on the board and took a picture to share with some people. I don't know what I could do. Maybe run this through iMovie and put the screen in there, and then you could see. What they wanted and what kind of actually happened. They just wanted like the vertical, the way they were doing stuff in pre-cal for here. It would just be up and down thing, like how far is someone vertically, not horizontally. But then I also did it considering the horizontal distance, using the distance formula. But something like knowing that the mom would not ever do this should be something that's immediate in our heads when we're reading some of this, because we should be so focused on reality. If that doesn't come up right away, then maybe we're just not thinking about it at the time. We all do some of that, but then we're not really being trained to think about the real world as we should. Our focus should be on what's going on in reality, not being lost in our head. What do you need at business? We're dealing with people. You should know what's going on in reality and not make stuff up in your head. That is not a good way to deal with people. But we also know that it's possible. This is going to happen. You can see maybe she can't keep up. Maybe she's standing there because she can't go around. But not, it turns out it'd be like going a 47.7 second 100-yard dash is all it would take. Because if the diameter is 8, circumference is 8 pi, and you can do it on your calculator. I've done this earlier, but I would just do this to show you. 8 pi, enter. 25 point, can you see it? Is it blurry? It's not even showing up. Okay, never mind. That's not going to work. You can do it on your own calculator. Ask Siri or your phone. Hey Siri, what's 8 pi? It disappeared. Whoops. But 25.12 feet. That's the distance around. And then change it into yards, divide by 3. Divide by 3. Enter. 8.37758 equals 8.37758 yards. Okay, so that many yards around. And it happens in 4 seconds. This goes all the way around in 4 seconds. So divide by 4. So we got the circumference, the feet all the way around. Divide by 3 to get the yards. 3 yard feet in 1 yard. Divide by 4 to get the time. Divide this by 4 to be yards per second. And we get 2.09. So speed, linear speed, 2.09 yard per second. And remember, when someone goes fast, 100 yards, 10 seconds, that's 10 yards a second. This would be about 10 yards in 5 seconds. And if we do this, 100 yards divided by answer, second answer, nope, second answer, got the right button, enter, 100 divided by 2.094395, enter, 47.7. So that'd be the 100-yard dash in 47.7 seconds. Can a mom do that? Yes, most everyone. I wonder what that'd be like. A really slow run or a walk, you know? A football field, maybe you could walk it in that much time. So yes, the mom could easily be going around to do that. This is something we should do with problems in general. Don't just mindlessly do it, but dig in, assess it, see what it means. You do something in kilometers per hour, it means nothing to people in the United States, to most of us. You should change it into, instead of kilometers per hour or whatever, or newtons, change it into pounds. You're talking about a newton in physics. What the hell does that even mean? What is a newton? It's about a quarter pound. Then we can get an idea of what the experiences of what it means in the real world, instead of just some floating thing we're clueless about. It should have meaning when we do stuff. Here, this is starting to have meaning and it's real, and that's what we need to do in the work world, in real life, when we do stuff in fitness, in economics, in home stuff, buying things at work. It needs to have meaning. And we need to start training ourselves to do that, to make it a habit, because it ain't going to happen out of nowhere, especially if we spend 18 years or whatever, like 16 years of an education, not doing this and being all floating. What are you going to do at work with all these bad habits? You're going to continue to do the bad habits, not know when you're doing them sometime. You have to break ones. Start having good habits now, please. You, yourself, your children. Dig in to see what stuff means, to see what's going on in the real world more than the problem requires. You know, like stuff in physics, stuff in chemistry. You can't do it for every problem, but we should do it for some to make it a habit. Peace.